Hello everyone, welcome back again in another video. Did you know that artificial intelligence isn't just the stuff of science fiction? It's a rapidly evolving technology that's already shaping our lives in ways you might not even realize. Imagine this: AI can predict disease outbreaks, compose music, drive cars autonomously, and even beat world champions in complex games like chess and Go. But that's just the tip of the iceberg. So if you want to make your career in the fields of artificial intelligence, this video is absolutely for you. In this video, we're diving deep into the fascinating world of artificial intelligence to uncover some mind-blowing facts that will leave you both amazed and inspired. Apart from that, we'll discuss some most important interview questions and answer for a machine learning engineer. So, let's embark on this journey to explore the cutting-edge advancements, astonishing feats, and the incredible potential of AI. Buckle up, because the future is now, and it's powered by artificial intelligence. So if you're ready, let's start today's video. What is artificial intelligence? Artificial intelligence, AI, refers to the field of computer science and engineering that aims to create intelligent machines capable of performing tasks that typically require human intelligence. AI involves the development of algorithms and systems that enable computers to perceive, reason, learn, and make decisions similar to humans. In essence, AI seeks to simulate human cognitive abilities, such as problem-solving, pattern recognition, speech and image recognition, natural language processing, and decision-making, among others. It involves the use of various techniques and approaches, including machine learning, deep learning, natural language processing, computer vision, and robotics. The ultimate goal of AI is to create systems that can perform complex tasks autonomously, adapt to different situations, and continuously improve their performance through learning from data and experience. AI finds applications in various fields, including healthcare, finance, transportation, manufacturing, customer service, and many others, transforming industries and impacting society in significant ways. What are the different types of AI? There are typically 4 different types or categories of AI, often referred to as AI levels or AI classifications. These types represent different levels of capabilities and functionalities in AI systems. 1. Narrow AI or weak AI. Narrow AI refers to AI systems designed to perform specific tasks or functions within a limited domain. These systems excel at a specific task but lack general intelligence. Examples of narrow AI include voice assistants like Siri or Alexa, recommendation systems, image recognition systems, and chatbots. Narrow AI is the most common form of AI currently in use. 2. General AI or strong AI. General AI refers to AI systems that possess the ability to understand, learn, and apply intelligence across a wide range of tasks and domains. These systems can perform tasks that require human-like intelligence and reasoning. However, achieving true general AI that can match or surpass human intelligence remains a significant challenge, and such systems do not yet exist. 3. Artificial superintelligence. Artificial superintelligence refers to hypothetical AI systems that surpass human intelligence in virtually all aspects. These systems would possess not only superior cognitive abilities but also an ability for self-awareness, creativity, and emotional understanding. Artificial superintelligence is purely speculative at this point and remains a topic of debate and exploration. 4. Conscious AI. Conscious AI refers to the concept of AI systems that possess subjective consciousness, self-awareness, and subjective experiences similar to human consciousness. This type of AI would have a sense of self and subjective awareness of its own existence. The development of conscious AI is a highly complex and philosophical topic, and currently, there is no concrete evidence or realization of conscious AI. It's important to note that while narrow AI is currently prevalent and widely used, the development of general AI, artificial superintelligence, and conscious AI are still in the realm of research and speculation, with no widely accepted or realized implementations to date. Explain the concept of machine learning. Machine learning or ML is a subset of artificial intelligence or AI that focuses on the development of algorithms and models that enable computers to learn from data and make predictions or decisions without being explicitly programmed for every task. In other words, instead of following a rigid set of rules, a machine learning system learns patterns and relationships from data, allowing it to improve its performance over time. The key idea behind machine learning is to enable computers to generalize from examples. Here's a breakdown of the concept. 1. Data collection. Machine learning starts with collecting and preparing relevant data. This data can be anything from text and images to numerical measurements. The quality and quantity of data play a crucial role in the success of the learning process. 2. Feature extraction. Features are specific attributes or characteristics of the data that are used to describe and differentiate instances. Feature extraction involves selecting and transforming the most relevant parts of the data to feed into the machine learning algorithm. 3. Algorithm selection. Depending on the problem at hand, a suitable machine learning algorithm is chosen. Different algorithms are designed to handle different types of tasks, such as classification, regression, clustering, and more. 4. Training phase. During the training phase, the machine learning model is presented with a labeled dataset, which consists of input data along with the correct outputs, labels or target values. The model tries to learn patterns, relationships, and correlations in the data that can help it make accurate predictions. 5. Learning patterns. The machine learning algorithm iteratively adjusts its internal parameters based on the provided data. It tries to minimize the difference between its predicted outputs and the actual labels. This process involves adjusting the model's parameters through optimization techniques to improve its performance on the training data. 6. Testing and validation. After training, the model is evaluated on a separate dataset, called the validation or testing dataset. This dataset was not used during training and serves as an indicator of the model's generalization ability. The model's performance on new, unseen data is a critical measure of its effectiveness. 7. Iterative refinement. If the model's performance is not satisfactory, the process is iterated. This might involve adjusting hyperparameters, settings that control the learning process, trying different algorithms, or enhancing the quality of the data. 8. Deployment and inference. Once the model achieves the desired level of performance, it can be deployed to make predictions or decisions on new, real-world data. During inference, the trained model uses its learned patterns to generate predictions or classifications. It's important to note that machine learning is not a one-size-fits-all approach. Different algorithms are better suited for different tasks and types of data. Additionally, the success of machine learning depends on factors such as the quality of data, the choice of algorithm, the design of features, and the expertise of the data scientists and engineers involved in the process. That's all for this video. We will discuss more about artificial intelligence and machine learning in upcoming videos. If you are new on this channel, please subscribe, like, and turn on bell notification for more videos. Thanks for watching.